Hello students, we will discuss Edexcel International GCSE Physics Unit 4 PH0 Paper 2PR May 2018. My name is Nariman Merlim. I am located in Baku. Here you can see my mobile and email. Students must have ruler and calculator. So this is the cover page, 1 hour. Let's go through. This equation will be given for you, so you should not learn them, but you should be able to rearrange these equations. Where necessary, assume acceleration of free fall 10 meters per second squared. Question 1. The passage is about static electricity. Use words from the box to complete the passage. Each word may be used once, more than once, or not at all. A student combs her hair with a plastic comb. Her hair and the comb becomes charged. This happens because of friction between her hair and the comb. The comb becomes positively charged, so her hair becomes negatively charged. The student's hair sticks out because like charges repel. When the student moves the comb through the hair, she can hear a cracking sound. This is caused by electrons transferring from comb to her hair. The photograph shows a machine used to crush metal. A metal is placed under the crusher bar. The motor pushes the crushed bar downward. The diagram shows what happens when the metal can is crushed. So we have force, and force has moved distance 16.3 minus 0.8. State the equation linking work done, force, and distance moved in the direction of the force. So work done equals force times distance moved in the direction of the load. Calculate the work done on the metal can by the force. Gives the unit. So work will be force, capital F, here capital F, by distance. F will 235 kilonewton. Distance is 16.3 minus 0.8, 15. So this distance minus this distance. And then when we calculate, we keep 3 significant figures because minimum is 3 significant figures, and you can put kilojoule. So either kilojoule or joule. So 42.6 kilojoule. Next question. 3a. Control rods or moderators are important parts of nuclear reactors. Draw straight lines linking each part of the reactor with its correct function. Control rods are used to absorb neutrons, and moderator slows neutrons. Describes the process of nuclear fission. Uranium nucleus absorbs slow neutrons, splits into 2 smaller nuclei. Here, mistake. Plural, emitting 2-3 neutrons at very high speed. Kinetic energy of the products finally turns into thermal energy. A student investigates magnetic fields. He places a bar magnet into a tray of steel pins and then removes the magnet. The diagram shows the magnet after it has been removed from the tray. I. Explain why pin X is attached to pin Y. Pins become magnetized. Top part is north, bottom is south. Unlike poles attract, so X sticks to Y. Write a conclusion for student investigation. Number of sticked pins tells about the strength of magnetic field. Strongest magnetic field is at the poles at north and south, equal strength. The student repeats his investigation using soft iron pins instead of steel pins. State what difference the student would observe. More pins attached. B. The student then uses an electromagnet made from an insulated coil of wire wound around a soft iron core to investigate this prediction. The strength of an electromagnet increases the current in the coil. Explain which is the independent variable in this investigation. Current is independent variable. Name two control variables in his investigation. The same number of turns, the same soft iron core. Describe the methods that the student could use to perform this investigation. You should include a circuit diagram. So this is a circuit diagram. We have variable resistor, ammeter, electromagnet, and battery. So by sliding the contact of variable resistor, we can change current and see how many pins are stuck. So use table to record results of measurements. Vary current by sliding contact of variable resistor. Count number of iron pins held by core of electromagnet. Repeat for 6 values of current. For each current, record number of pins twice and use average. So for every current, we repeat experiment 2 times and use average. Question 5. A space probe was launched in 2007. Its mission was to visit Ceres, a distant dwarfed planet in the asteroid belt. The space probe sends data back to Earth as the radio waves. The sketch graph shows how the radio wave changes as the radio waves travel in free space towards Earth. So free space, it means that the speed everywhere will be the same. State what happens to the amplitude, wavelength, and speed of the radio wave as it travels in free space towards the Earth. So we see that amplitude is decreasing, wavelength is distance between crests, it stays the same, so it's constant, and speed is constant because it is free space. Right. Double I. When the probe was near Ceres, it was difficult to steer the probe by remote control from Earth. Why was it difficult to steer the probe by remote control? Here the most likely, the answer is there was a time delay for signal traveling to probe from the Earth. 3i. The radio signals sent to the probe are digital. Which rows of the table gives a correct comparison of digital radio waves with analog radio waves? So the best answer is digital travel at the same speed, but analog is harder to remove. Which of these is digital signal? Digital signal consists of steps, so steps we see in B. The space probe has some solar cells to provide electrical energy. The total area of the solar cells is 36.4 meters squared. When the space probe is near Earth, each 1 meter squared of solar cell generates so many kilowatt. Calculate the electrical power generated by this solar cell. So we convert kilowatt into watt. Total will be number by each. So we get answer with 3 significant figures because minimum is 3 significant figures, and we keep 10.0 kilowatt. The probe is propelled by an iron thruster which produces a force of 91 millinewton. Calculate the change in momentum that this force produces in 25 minutes. So 25 minutes we turn into seconds, and we use formula from the list that I showed you at the beginning in the examination paper. Force equals change in momentum by time. Rearranging gives us change in momentum equals force times time, and two significant figures because of 91 millinewton give us 1.4 kilogram meter per second. The diagram shows a simple generator. The coil of the wire rotates at constant rate. When the coil of wire rotates, the voltage can be measured across the contact. Use the grid to sketch how the measured voltage varies as the coil of the wire rotates. So it is a sine or cosine function with constant period. So here we have Constant period is from here to here. Question 7. The photograph shows a fruit seller using a yard arm to weigh fruit. The yard arm consists of steel bar about 1 meter long with a basket at one end and movable weight at the other end. It is held up by a hook which is fixed to the bar close to the basket. The diagram shows a yard arm being used to find the weight of the 5 bananas. Draw an X on the diagram to show the pivot point. So pivot point is here. So basket of bananas produce anti-clockwise movement, so force applied at smaller distance and movable weight at longer distance provide clockwise moment. State the principle of moment. At equilibrium, sum of anti-clockwise moment equals sum of clockwise moment. Clockwise moments. The support for the basket is 40.1 centimeters from the pivot. The movable weight is so much and weighs so much. Calculate the weight of the 5 bananas. Ignore weight of steel rod and basket. So weight times distance equals another weight times distance. So rearranging for weight of bananas, keeping 3 significant figures, we get 750. Calculate the mass in grams of 1 banana. So weight of 1 banana will be 5 times less. We divide by 5. And weight equals mass times g. So mass equals weight times g. So mass weight of 1 banana by 10 gives us 150 grams. So just 2 ways that the fruit seller could alter his yard arm so that he could measure the larger weight. So either you make longer distance for the small weight to move along, or smaller distance from the pivot to the basket, or heavier weight. So 3 variables we can change. Electromagnetic radiation can affect human body. Discuss how excessive exposure to electromagnetic radiation may cause damage to human body. Refer to the different parts of the electromagnetic spectrum in your answer. So any 6 from. So high intensity, high amplitude and longer period of exposure produce excessive damage. So radio waves, no damage. Microwaves can cause heating of body, especially brain cells. Infrared radiation can cause surface burns to the skin. Visible can cause vision impairment. Ultraviolet can cause skin cancer. X-rays can mutate or kill cells inside the body. Gamma rays can mutate or kill cells inside the body. Paper is over. Thank you for your attention. See you next time.